Hello, hello. Okay, ready to go. So, I've been getting a lot of questions on stream that kind of ask me, how do I make a game? Um, so, I thought I would take this opportunity with the Global Game Jam going on to make a game in 3 hours, over three sessions, so an hour each, and yeah, kind of show my process. I'm by no means, Mr. Genius game maker. So kind of take it how you may. My process might not be, the best, most amazing process, but yeah, works for me. I think the games I make are fun, and I enjoy making them. So, yep. So the Global Game Jam is interesting because it's a community event. It's not really meant to be a solo event, and I'm kind of soloing this. And yeah, it's so I'm not officially in the Global Game Jam, just as a disclaimer. But I'll pretend like I am, and show you everything as if I was, and hopefully at the end of it. I can share all the source code so you can take a look and see and tell me how bad my code is. Cool. So I am gonna start with a small kind of design doc, just something for me to refer back to in case I forget what I'm doing. The theme of the jam is duality. So big, small, quiet, loud, etc., etc. And it's a small game, so my scope is going to be small and tiny. Um, I was thinking I'd make an FPS, which is kind of general. People like FPSs, people make FPSs. And something kind of in the vein of Metroid Prime, which is one of my favorite games ever. And we're gonna do it in Unity because that's what I know. You know, I'm not, no, Sean, sorry, I'm not Mr. Genius Game Maker. I've oversold myself to you, sorry. Um, yeah, Unity because that's what I know, that's what I'm kind of warmed up on. A game jam, by the way, is like not the place to learn something new. Font bigger, sure. Works? Yeah, and my interpretation of the theme is gonna be like super boring. You're either gonna shoot white or black, and you know, black damages white, white damages black. You can absorb shots that are white, and yeah, it's kind of like the most generic, newbie interpretation of this theme ever. But yeah, I mean, we're kind of learning how to make a game, not trying to innovate on games. Cool. That's it. That's my design doc. Short and sweet. We're gonna make a new project, and it's gonna be a 3D project using the bog standard, you know, bog standard GGJ fake. Make a game in 3 hours. We're gonna use the bog standard renderer, packages, whatever. Let's not make this complicated. If you're expecting Halo at the end of this, sorry to burst your bubble. It's probably going to be a bunch of cubes attacking a bunch of cubes, and that's it. I wonder if I should like put this somewhere on the screen. project gets created. Gotta love Unity. It takes so long to load anything. Yay. I'll just put in the game design doc on the screen, so if anyone asks, I can just pop it in. There we go. Sample scene. That's how you ship a game. Don't rename your scene. It's a sample. Customer will never know. Cool. So a bit of organization. I'm gonna use some of the assets that come with Unity that you still have to install, like ProBuilder, just because it's fast and doesn't take forever to build things in ProBuilder. So we're gonna do ProBuilder. And Text Mesh Pro is already in there. Cinemachine is a good one to have because it so you know, for people who don't know Unity, ProBuilder lets you build kind of prototype geometry really quickly. It's nice in that way. It lets you really not burn a lot of time building geometry. The intent of it is you build the geometry and then eventually replace it with production art. But I ain't no artist, and what you see is what you get, and this is my production art. So yeah, it is what it is. Cinemachine. Let's install that. And if you're gonna make a commercial game, there's tons of stuff that I recommend, and they're, you know, you gotta buy them, unfortunately. But you know, stuff like they've got a what was it called? I'll look it up later. I'll post it somewhere. But you know, kind of the default shader graph that comes with Unity is actually really inefficient. It's still under development. There's a couple of alternatives that actually do a better job, and highly recommended. Anything else I think is core for now. Nah, we're good. I think we're okay. What you want to do is bring up the ProBuilder panel window and kind of dock it somewhere. So if I dock it somewhere, I'd even dock things. How do you even use Unity? And I like a 2-column view. Is it? No, 1-column view. 1-column view, but small. It's a massive view. This is okay for me. New shape, start with a cube, and you know, we'll make a bit of a cube here. And that's gonna be our initial world test area. First thing you should do is give yourself some space to kind of do stuff, because why not? And then, you know, test geo. Right, character controller. So you've got a main camera, that is going to show you the world. That's how you see the world. You've got, by default, a directional light, which is the sun, somewhere. If you double click it, you can get to it. Ah, it's hidden below this somewhere. And then our test geo. So a bit of organization. And this is something I wish we started doing with M&M, and I'll probably go back and do this type of stuff. But we're going to create some kind of scene dividers, and we're going to call them game essentials. This is what the game won't run without. And say geo, lighting, because even though there's just one light in there now, you know, just give this to Nick for a second and he'll put in 7,000 lights. And then we're going to have entities. That kind of gives us a bit of a visual separation between things, kind of categorization. Helps us keep things aligned. Cool. What you want to do is try to use prefabs as much as possible. Like anything that you can make into a prefab, you should. So prefabs are kind of like copies of something, right? So you're going to have a prefab is kind of the original, and then whenever you instance something into the world, it becomes a copy of that, which then can have its own kind of variables and stuff. But it lets you be very organized in the way you do things, as much as possible. So things like this test geo, that doesn't need to be a prefab because it's kind of a one-off, probably get deleted soon, even later on when we start putting in actual geo. They'll probably be their own scenes, and so you don't really need to prefab them. But the player, right, the player themselves is something that you want to prefab, because you want to spawn that player into a new map, which is how that works. I think probably let's reset the position of this, and then we will move it down so that it is just at the world origin, just under the world origin. That puts our player on top of the world, which is always good. So the player. First we want to kind of create the player. We're going to build up the pieces of a player, which, at the most basic is a collider, so a capsule collider. That defines kind of like where is your character, what size they are, etc. So your character is going to collide with the... What's going on? Huh. A collider isn't visible. It's supposed to be visible. I noticed that with M&M as well yesterday. For some reason, colliders don't show up unless you've got some geo attached. But, anyways. And for now, what we can do is actually place the camera attached to that player. So player's over here, camera's over here. Just reset the position of that. And we'll bring it up ever so slightly, so that it's about a meter and a bit up. Say 1.7. most people are like 1.6 to 1.8 meters high, so 1.7 feels natural. Yeah, but I know why. It's because this needs a body. Character controller, right? Sorry, you need a character controller, not a collider. Still in my Godot mentality. So at the most basic, that's a game, right? You've got kind of a physical representation of yourself in the game, and then you've got a camera to see out of your eyes, basically. And if you hit play, you can't do anything. But that's it, game done. Who said you need 3 hours? 15 minutes, more than enough. Right. Sorry, someone sent me a message. Yeah. So the way game engines work typically is they'll kind of have a objects manager. So that is the kind of, sometimes it's a scene hierarchy, sometimes it's just a kind of a list of objects, and Unity is kind of traditional, it's got a scene hierarchy. So this is a tree, right? You've got a root node, which is the sample scene. Then you've got player, which is under entities. So you've got entities, which is a blank. You've got a player, which has kind of the player specific things, and then the player has children, like the camera. So whenever you move, the camera moves. And kind of the next, the kind of the objects have components. That's as well a basic model that's shared between many game engines. Components are kind of like these little chunks of logic that act on the object, or might act on different objects, but for simplicity's sake, let's say acts on the object. So if you've got a movement controller, movement component, that moves the object. If you might have a jump component which handles jumping or whatever else, right? And what we can do is actually create one. So we're going to create a new script, which is a new component, and we can call it player movement, right? And kind of basics of making a game. Scripts, keep it organized. And if I'm being a bit too basic, sorry. Like, I know this is something a lot of people know, some might not, but a lot of people understand this kind of concept. Something acting on something, whatever. Open up the code. Unity, C#, again, a lot of people know that, but C# is a great language for game design and game development, because it's object oriented, which is good. It's very corporate minded, corporate designed. It's meant to be something that's easy to get multiple programmers to work with without clashing. It's also takes out a lot of the boilerplate that comes with C++ and C. It kind of knows how to deal with itself, and then it's very modular, so it's easy to get other people's code, for example Unity, and plug it into your own project. So we don't need to care about getting the kind of the game running, because those are all components that, sure Nick, I can make things bigger. Better? Is it too big? Let me know. Yeah, so as I was saying, it's a great language for game development, honestly, and a great language for anything, any type of development, because of these things. You don't have to care about how to get this game running, because it plugs right into Unity, and then Unity takes care of that. Cool, thanks Nick. It takes care of that for you, and all you need to worry about is that you've got a behavior, a mono behavior, which is a Unity behavior or a component that has two hooks, a start hook and an update hook. And what those do is update it. Obviously, it's called once per frame, and start is called before the first frame update. So as soon as you're going to update for the first time, if you've never started this object, you start and then update. And in start, you kind of do all the initialization. So you want to operate on this player entity. And in this case, we want to do that by moving forward. So the easiest way to do that is, and you know, in anything programming and anything game development, there's multiple ways to do things. There's kind of a best practice. There's a, you know, other creative ways people do things, and some of them can end up very buggy. Others not so much. But we're gonna do like the bog standard way of moving something for now, just to show that. You wanna move your, like, if you move your position, your character moves. So when there's an input, you want to change the position. So in this case, the way we're going to move the position is by using the character controller, which is a plugin, is a module, is a component, which takes care of everything physics related. So when you're moving, do you collide with something? Do you fall through the earth? Do you, you know, anything else? That's how that happens. Is that Unity takes care of that. You tell the character controller, I want to do this, and it checks, can you, you know, how much can you move, and do you collide with anything else? So what we do is we want to character controller. So we want to grab that character controller, bring it into our component, and start acting on it. And the way we do that is, before, you know, we want to check, I mean, we want to initialize that first, but before we do that, we want to think, okay, what do we want to do? And what we want to do here is we want to use Unity's input detector, basically, and we want to check if a key is up or down, right? So get key, and the key we care about is W. So key code W, because WASD. So when we have W down, we want to move our character controller, and the way we do that is we're getting the character controller, and then we are setting its velocity to new vector 3 with a velocity of, well, I mean, just to see what happens, right? X 0, Y 0. So F means it's a float, so 0F is a 0. It's you don't really need to in this context, but it's good practice to always put in the F, because if you start going into decimals, 0.5 is a double, not a float. And the difference between a float and a double is that a double is a double length float, so it goes to a much higher number, and a much lower number has a lot more precision. But it's you know, we don't need that here, because vectors take floats, not doubles. So we want to specify that this is a float by putting in an F. Anyways, 0F, 0F, and we want to move forward. So every game engine uses different coordinates, like an axis. It's super confusing. Link those to Jasmine. Yeah, I mean, I was hoping you'd upload this into M&M, and then you can you can link him to her. Okay, so every game engine uses different coordinates. Sometimes they tell you left hand, sometimes they're going to tell you right hand, and you know, sometimes Y is up, sometimes Y is forward, sometimes Z is up, sometimes Z is forward, sometimes Z plus is forward, sometimes Z minus, like a negative Z, is forward. It's, you know, it's crazy that so long. It's been so long that people have been making games and no one has agreed on a coordinate system, which is kind of the first thing people say when they're arguing against NFT interoperability. You know, people are like, yeah, buy an NFT, it'll work in any game, and then a lot of people are like, no. And that's kind of the first argument that people put in. Can't be assigned to it, right? That's one of those things. You gotta know which way you have to move things, and that's all available on the documentation of whatever engine you're using. In this case, character controller actually needs, you need to put in how much you want to move into your move function. So in this case, we're telling character controller to move -1. So, you know, what is that gonna do? Well, hopefully, if I haven't done anything stupid, it's gonna move us forward once I hit W. So 1, 2, 3, W. Oh, something happened. So now this is kind of debugging 101. You look at your log, what's happened, null reference exception. That means you've tried to access something that doesn't exist. And in this case, what doesn't exist, I mean, if you click it, it shows you what line. So line 19, you can click that to go straight to it. And what doesn't exist here is the character controller, because you've never grabbed it. It's an empty null reference. So before your first update, just before your first update, you want to populate that. You want to point that to the character controller. So the way you do that in most programming languages, and then also specifically C# and Unity, is you're going to assign something to that. Because this is a reference, this is a pointer. It tells you, it's not a thing by itself. Like, it's not a new character controller. It's pointing to an existing character controller. So we want to point it to the right one, right? Maybe you've got 10 players and you don't want to move everyone when you press W. So this is attached to the player, and you can grab your own stuff by just saying get component and then telling it what type of component. In this case, it's character controller. And that's it. Now we've got, we can access it. Once we click this again and start the game again and press W, whoop, wrong way. So you see we moved backwards, not forwards. And the reason for that is, let alone no one can decide which one's positive, which one's negative. Depending on your rotation, positive and negative are going to be different. So, for me, most of the time, I'm going to do it once, and if it doesn't work, I'll just flip the sign. It sounds stupid and random, but, that is the truth. That's how I do it. And then I'll just make sure it's consistent for everything else in the game. So now we've moved forward. And if you saw, it was very fast. And the reason for that is because 1F is a unit, and this runs 60 times a second. So basically, every time you just you hold W down for a second, you've moved 60 units. Now, what is 60 units? It's arbitrary. It's kind of whatever you want 60 units to be. It could be just a random unit. It could be feet. It could be meters. Now, I'm metric, so I tend to have a meter be a unit. It's fairly common, fairly standard to use the metric system in game development, but whether it's a meter or a centimeter or a millimeter is kind of up in the air. I believe Unreal uses centimeters, so it's 100 units to a meter. But it's it wants you to use that, doesn't mean you have to. It just depends on what size you make things. So I set the camera up 1.7, which is 1.7 meters in my world. So this is going to be a meter. But this, kind of the easier way to what you have to do now is you have to scale this by time, right? Because you don't want to move a meter every frame. And in fact, tying anything to frames is a bad practice because you might have frame lag, you might have whatever, so you want to kind of take that out of frame land and take it, and tie that to real life time. So what we can do is actually take a delta time, and Unity makes it very handy. It has a variable, like it has something you can refer to every frame, and this will tell you how long did the last frame take, which is very similar to what this frame is going to take. So that gives you a good reference to know how much you should be moving forward. Then the other question is, how fast should you be moving? And again, every game is a bit different. What works for you might not work for me, what works for me might not work for you. But let's be kind of adventurous here and say my speed is 8 meters a second. So the way this would work is you want to move speed times delta per frame. And we play again, and yep, movement is now not insane. Cool. So now we can move forward. Let's work in the other directions. So you kind of want to take every direction, right? And say, what if we have S held down, or else if S held down, or A held down, or D held down. In fact, we don't want these to be mutually exclusive because you might hold down multiple keys. So actually each one is its own if. And where the parentheses are and all that, that's all stylistic. Like I've got taught how to program with, I don't know if you've seen Silicon Valley, but a couple on that show break up because one places parentheses here and the other one does it here. But programmer humor, not very funny. So what we want to do is actually kind of get a net vector out of this, right? And then make that our movement. So if we took this and actually applied the movement after we know where we want to go, then we can kind of take a input vector, which is a a new vector that's 0, and that's just a shortcut. That's the same as saying new vector 3 0 0 0. You can do either or. The other one is just a shortcut. And then we want to kind of influence that by seeing what our input is and then change it. So in this case, what we can do is if W is held down, and I can't remember if I can like directly add things. Is it read-only? No, it's not. Okay. So if we, we've learned that positive Z is forward. So if we're holding W, we want to add 1 to the Z coordinate. And then if we're holding back, then S backwards, we want to reduce it by 1. If we're holding A, here, I'm assuming X is left and right. Again, who knows? If you set it up differently, it could be different, but it's a fairly good guess. And D is kind of right, which is positive X. And what we want to do is take that vector, instead of taking a new vector 3 here, now we've got an input vector, and we just got to turn that input vector into a velocity, right? And you can call it velocity vector or just velocity. I mean, again, it's kind of all up to you. But the velocity vector is the input vector times your speed times delta. Makes sense, right? If you're moving forward, then this is 1 times 8, and then times whatever your frame speed is, taking it back to, 8 meters per second. And that's what we want to move by. And that is us moving. But you might ask, what about turning? To which I'd say, good question. In order to kind of move in 3D space with an FPS, first-person shooter game, you need to be able to turn around, and you turn around by either going super old school and using the arrow keys to turn around, or be a little bit more modern, and we're going to use the mouse. Now, funny thing about mice and game engines, the moment your input is mouse, everything becomes 10 times more complicated. It sucks, but it is what it is. So what we want to do is now know where we want to rotate, right? And to do that, we actually want to make this a little bit more robust, because now the camera moves. You've got a camera and you've got a player. When you turn the camera, that changes where forward is. So you want to rotate the player to wherever you're facing, right? So if you're going to turn left, you're going to turn left, and now forward is to the left. But when you look up and down in a game, that doesn't change where forward is. If you look up and you walk forward, you're still going to walk forward, not fly up, unless you've got a flight controller basically and you want to fly. But if you're playing kind of, your movement is on a 2D plane, which you can rotate in, but up and down is just a look, like that's where you're looking, but it doesn't influence where you're moving. And so the way to address that is you're gonna have your player rotates, but your pitch is only reflected on your camera. So only your camera moves a pitch, your pitch only moves by camera. Now, you could do that by just influencing the rotation, the X rotation on the camera, and that gives you the same effect. But you also want to kind of influence, let's move this up a bit. Where's our player? I think our player is a little bit below the world, which is why it kind of pops as soon as we start. Oh yeah, because this, you know what? Duh. Okay, so we want to move this. So the collider doesn't start from here and goes up. It's both up and down of this. So we want to know kind of where our, that should have been more organized, but okay, so 0 is 0. We're 1.7, so we actually want to move this up by 1.7 divided by 2. So 0.85, because now the collider is above and below that. And then this camera at 1.7 is way too high. We also want to move that down by half, I think. We'll see. I mean, if this ends up being, it'll be actually a bit weird. Let's just move it slightly so it's more in line with like real life. Yeah, sorry, before I went back on that tangent, I was saying, so pitch doesn't affect our movement, right? Like we're gonna still move forward even though we're looking up. We're gonna still shoot up if we're gonna shoot something. So we don't want to just do the camera. We don't want to just pivot the camera. We want to pivot everything that's under our pitch. And that pivots around where the camera is right now. So, 0.79. I'll put that here, and then we're going to move the main camera under pitch, which then, you know, that goes to 0 because it knows compared to this, it's at 0, 0, 0. And that, you know, brings us to one of the main concepts of any game engine. And this differs slightly between engine to engine, but it's pretty similar, which is, you know, it's easy to kind of reference yourself, like here, you know, we just got character controller by just calling get component, but it's not as easy to have one thing reference a different object, because even though this is a child, it's still a different object. So how do we influence pitch from player? The easiest way to do that, and most straightforward way, but if you start scaling this up, it's going to be like spaghetti. So this is something that works. It works when something is local, when something is not going to change. It's always going to be there. You know your player is always going to be spawned in with a pitch, and it's going to do that automatically because they're going to come together, you know, on a package. It's fine to do a direct, like, one-to-one connection. If you're looking at influencing lighting, for example, from player, it's very bad to kind of do it this way, because that's just gonna, you know, you'll manage and keep a mental map of like 5, 10, 20, 500, but you know, most games are massive and you're gonna have a lot of references. So the way we do that is we're gonna take so I like to keep my constants in the top. Actually, I also like to, here's a little tip, you can, if you right click and rename, you can change the variable everywhere in your project. My constants, I like to keep them in all caps so I don't forget that they're a constant. But I like to have my constants first and then my public variables, and this is kind of a very like traditional way of coding. I don't know if it's in fashion yet, or I'm just old-fashioned, but all my publics are going to go there. And public, you know, private, public, etc. Private means you can only influence it from within your own thing, and public means you can influence it from outside, like from different objects. And those are the two basic ones. There's a couple of other ones, but you know, you'll be fine if you just know those. So what we want to do is we want to give ourselves a reference to the pitch, but the pitch is transform, because we want to transform it by rotating it. So, and every object has a transform component by default. So we are gonna reference the transform of the pitch object, I guess. And this is a public. We don't need to initialize that, because what we're gonna do is, now that we've got a public variable, it's actually gonna show up here. And all we have to do is grab pitch and put it here. And now we have a reference. So when we are going to pitch, now we can pitch object dot rotation. And now we can influence the rotation however we want. I'll just leave that commented out because we need to first figure out how are we influencing that. Cool. So we are going to do a couple of things. First off, when the game starts and we're going to initialize into this, we need to lock our mouse. How do we do that? Mouse lock? Oof, I don't remember actually. I gotta see how that works. Times like these, we've got docs. So on my other screen, I'm just gonna look up Unity mouse lock really quick. Right, so not input, but there's another kind of cursor is the object. So what we want to do is we want to grab the locks. We'll change the lock state to locked. So that locks our cursor. The thing is, if you did this, the moment you hit play, it's going to lock, and then you're going to be trapped. So you know, there are more elegant ways to do this, but kind of the simplest one is if input dot get key down, which is the moment you press the key, key code dot escape. We wanna add a new module. So modules give you access to things. Unity Engine gives you access to all the engine's properties. We're now doing something in the editor. So you've got access to Unity Editor as well. And you can just, you know, editor application. You can look at all these things up in you know, the docs. You can just exit play mode. As you learn your engine, you learn more of these, and you kind of have them memorized. So now when you hit escape, even though your cursor is trapped, and you can't click exit, you can just press escape to exit. It's kind of a ripcord. So this is here. We'll just give this a quick label and say this is movement. We want to now get rotation. So for us to get rotation, first we got to know, now that we know our mouse is locked, it means that when we move the mouse, it's going to register that, you know, register that. So we want to know how much we've moved the mouse, right? So we're going to grab mouse movement from input.mouse. Actually, new concept, because it's actually better to do it this way. Keys are easy to kind of grab this way. You can just pull a key. Is it held down or not? And you can do that every frame. Whereas rotation and mouse, like I said, once you introduce mouse, everything is 1,000 times more complicated. You don't want to pull where your mouse is, because if you're in locked state, your mouse is actually always in the center. You just don't see it because it's locked, but it's always going to be in the center. But what you can do is actually capture events. Like when you move, it'll capture that event of you moving. Yeah, so good time to refer back to my docs right here. We want to capture that event, and the way we do that is we use just a sec, let me look this up really quickly. Actually, let me take that back. That's how we do it in M&M, actually. We've got an event listener, and it captures those events. And, you know, even our inputs, we don't grab them directly here. We capture those events, and then we pass them off to everything that needs it. But since this is a simple game, and we don't want to go into, like, super complicated concepts, there is a Unity shortcut that exists for this. So we can grab rotation as is, and the way we do that is we can grab mouse X, and that is input.getAxis, and that axis is called mouse X. And the same for Y, and that is our kind of movement, mouse movement. And there are two floats, so a float for X and a float for Y. Now you could combine these into a vector, but not really needed. The main thing you want to do is you want to correlate this to a speed of, you know, pitch and yaw. So pitch, yaw. How fast do you want to rotate? How fast do you want to pitch? Most of the time they're pretty much one-to-one. You want to do them at the same speed, but there are situations where that's not the best way to do it for certain types of games. So we'll just keep them separate. We'll say yaw speed, and let's say we can spin, you know, let's do that at 180, so it's 180 degrees. And this is again completely arbitrary. This might be too fast or too slow. I don't know. But we're gonna check it and then come back and modify it. So now that we've got our X and Y, we're gonna say pitch delta. Actually, let's start with the yaw delta because just X before Y. Is mouse X times our yaw speed times our frame time, so delta. Similarly, pitch delta is mouse Y times pitch speed times delta. And that gives us now an amount of pitch and yaw to move, which hopefully all works, but if it doesn't, we'll see why. So now we want to actually have that do something. Let us influence yaw first, since it's simpler. How we're going to do that is by changing the rotation of our character, of our object. So even though we've influenced character controller here, character controller actually doesn't care about what direction you're facing, because it's a move in global coordinates. So you're telling it here you're moving this in this vector, regardless of how you're facing or you're rotated or you're upside down or whatever. That you're always going to move in the same coordinate system. Whereas your object has its own transform, which means it has its own coordinate system which influences all of its children. And that means that when you rotate, you want to influence your player, and then you want to feed that back into your character controller's move function. And it'll make more sense when you see it, but the way that works is we want to now rotate our player first. And now that we've got a yaw delta, we know how much we want to rotate. It's as simple as just grabbing the transform, which is this object's transform, and rotation. And a bit of a tip, actually, before we do that. It's very simple to just modify a rotation, but it can get very hairy if you do that. And the reason for that is because now you know what's your rotation. When you want to pull that rotation back, the math is a lot more complicated and time consuming to go backwards from an existing rotation into a kind of direction in vector form. And it's actually very slow as well. So there's a little tip I want to give you, which works for any engine and which is give yourself a actual yaw and pitch. Oops! Ooh, what happened there? Pitch variable. So we're gonna set this. We're gonna set these both to 0 to start with, and then we're gonna set that, and then we're gonna use that to set the rotation in like real terms. So it's not a relative yaw, but a actual yaw. So the way we do that is now we've got a yaw delta. We want to take our yaw variable and we want to add the yaw delta to it. Yawn, because I'm sleepy. Actual yaw delta. And then once we have that, we're gonna transform our rotation, not plus or minus, but we're actually gonna set it, and we're gonna use quaternion, if I can learn how to talk, which is a representation of rotation. And you can look this up. It's a mathematical thing, but definitely more than 3 hours worth of explanation if I was going to go into what a quaternion is. And we're going to use Euler angles, which is an even simpler representation of a rotation. Euler angles aren't as good as quaternions at representing rotations, and that's because they're highly sensitive at the poles. So if you're looking straight up or straight down and you move, and it has this like Euler drift where things get less accurate over time. But because we're setting a new Euler angle every time, we don't care, because we've got we've got actual representations of our yaw and pitch as a float, and we're just going to set that every frame. So we don't care about any drift. We don't care about polar sensitivities. We just want the simplest way to make this happen. And the simplest way to make that happen is to take take your yaw and apply it to the y-axis of your rotation, of your Euler rotation. And if I didn't do anything stupid, when we move the mouse now, let's hit play. First of all, locks my mouse, and then when we turn, we turn. Cool. So it's a bit insensitive. We probably should increase the sensitivity from, kind of from where we had the speed at 180. We should probably increase that, maybe 360, maybe more. I think 400 or 420 is what I use usually. But yeah, that's it's preference, and also likely you want to make that configurable in game. But now that we're doing this for the first time, it doesn't really matter. But anyways, two considerations now. Now that we can rotate, point this way. When I hit W, I'm actually not going to walk in this direction. I'm going to walk in the global coordinates, and the reason for that is, like we said before, the character controller doesn't care where you're pointing. It's moving in global coordinates. So we want to take our rotation now and feed that back into our velocity. The second thing is, if you look in the top right where it says transform under player and inspector, I can't show you with the mouse because it's locked, but that's what I was saying. You're trapped. You're trapped once you lock your mouse. If I keep rotating and I go past, oh hey, is that cool? Cool. Why does it reset? I have no idea, but it's very cool that it does. Oh, you know why? Because Euler resets it. But the actual representation of the yaw float in game, in memory, is still increasing. Like, it's now gone to past 720, and it keeps going negative 720, and you can keep going. It'll go negative 1,000 something and 2,000. And if you keep doing this, and you go to a really big number, you lose precision, and then your controls get really wonky, and that's really bad. So the way we solve that, and perfect timing. We're about to finish our character controller, and we're about to run out of time. The way we solve that's escape, pull the ripcord. The way we solve that is that yaw, after we add everything, we want to take a modulus to 360. What that means is it's going to divide it by 360 and take the remainder. Now, people who know programming will look at this and be like, aren't you taking a modulus of a float, which doesn't work? Modulus typically only works with integers. But in C#, that's not the case. They've given you a modulus for floats. In many other languages, you're going to have to tap the game engine's math library to take a float modulus. So just keep that in mind if you're doing this in a different game engine. But for Unity, you can just throw a modulus operator right there, and you're going to divide that by 360, take the remainder, save that into yaw, and that will make this would mean that yaw is always between 0 and 360, which is perfect. Now, we said we want to take that and multiply that back into the velocity, and the easiest way to do that is to take transform again, and we're gonna take a forward vector. So now we take a forward vector that is basically taking your forward facing and just multiply that by the is it multiply? It's not, because you can't multiply two vectors like that. What was it? It was quaternion times forward. Right. So I think what we want to do is build our rotation again. Quaternion dot Euler 0f Yaw 0f again, and multiply that by velocity. Yes. In Godot, you can grab forward, multiply that by velocity, and you're done. But I think in this you have to do this. So it looks like I'm going to go slightly above the time, so not so pro, Sean. But this should, see now, whichever direction you're facing, you should walk in that direction. So I'm going to do looking up and down, and then you know, we can call it for today. So the next thing we want to do really quickly is influence our pitch. I mean, let's move up the speed first, because it's really frustrating actually. I gotta move the mouse a lot to get anything done. Time is gone, so let's just hide it. And yeah, so that was yaw. We wanna deal with transform with the pitch next, and it's literally the same. We're gonna do pitch plus equals to pitch delta. And the thing we do with pitch is you actually can't pitch infinitely. You can't like kind of go all the way back there. So the easiest thing to do in this case is actually to just limit your pitch. And the way you do that is Unity has a very handy, you know, float math library, and in that they've got clamp, which clamps a value, in this case pitch, between a minimum number and a maximum number. So we don't want to ever go less than -90, and we don't ever want to go more than 90, which you know, kind of straight up and straight down, and we want to limit that so that we don't pass those limits. Then, if you remember, we have a pitch object that we've saved up here, right, in this variable. So instead of influencing our own transform, we want to influence pitch object's transform. Sorry, it's already a transform. I don't need to grab transform of that. So just that, and then we want to set its rotation to a new rotation quaternion that we're building from Euler's, which up and down, that's up and down, x-axis in our case. So we want to take our pitch as our x, then 0, 0. And if you were being pedantic and you'd say, why are we building this twice? Well, probably shouldn't. We can yaw rotation, set that, and then we're going to set that to yaw rotation. And then instead of rebuilding this again, we can use yaw rotation. So in this case, this pitch object's rotation does not affect our movement. And if we hit run here, we can look up and down, but a few issues now actually. Few issues. First of all, our rotation, I'm actually rotating and it's not doing anything. And I'll tell you why in a sec, but you can see the rotation figure moving, and even our forward changing, but we're still looking forward, which is very trippy, but you know, simple fix. The second thing is it's like flight controls. When I pull back on the mouse, I'm looking up. Both, you know, things you'll find in trial and error. Simple solution: your pitch take negative pitch. That flips everything. So now it'll feel right. Second thing is we're setting rotation, which is rotation on the world coordinates, on the global coordinates. We don't want to do that because we are rotating the parent independently of the pitch object. So what we want to do is actually influence our local rotation, and that solves that problem. So hit play, and now looking down looks down, up looks up, speed feels good, movement feels good. We can move, we move in the right direction. Happy days. This is great. Yep, so that's a first-person controller. So I said 3 hours. Now I'm thinking if it took me an hour to do this while explaining, it'll probably take me a slightly more than 3 hours to build a basic game. But yeah, this is us with a character controller. The base of any game is your character controller. That's how you interact with the world. So the fact that we've got this done is great. It means we now have a physical representation in the world. There's a few caveats to that. One is we don't actually have gravity. Woo, you can fly. And then also you can't jump because we didn't tell it how to jump. But, you know, we can move. Happy days. So next hour, what I'm going to do is I'm going to show you adding gravity, jumping, and then shooting. And with that, you have a pretty, set up game. So yeah, thank you for tuning in, and I hope this helps people. See ya.